Morning, everyone.
Morning.
Welcome to this session, FileMaker and Graph Databases. Let me first check this is not a session about charts or graphics. So if you're expecting that, this is only about a revolutionary new database engine. But if you're here for charts, then maybe it's your chance to switch to another session. My name is Joris Aerts. I'm co-founder of ClickWorks. I started my career with FileMaker back in 1996, when it was Claris at the time. So it's exciting for me. I feel young again. I started as a teacher, so I've been given trainings on FileMaker, but also Microsoft Access, Visual Basic, SQL Server, and so on. But in 2005, we started focusing on FileMaker with ClickWorks. I started a company together with my brother, and we are now a team of 10 people based in the beautiful historic town of Antwerp, Belgium. We are a platinum partner. I'm certified every version since it became available, and I'm a regular speaker at European conferences in Italy, Sweden, France, UK, and so on. You can talk to me, if not about FileMaker, then about sailing. I'm an avid dinghy sailor, or guitars, or electric vehicles. These are my passions. Now, the topics for today. There are two main parts. There's an introduction to explain you what graph databases are and why they can be important for us. Is there anybody in the audience who has already experience with a graph database like Neo4j? Okay, so this will be a journey of discovery for you as it was for me 1 year ago. Great. So I will explain to you what a graph database is with some simple examples. And then I have 3 demos for you to show different levels of integration between FileMaker and the graph database. First, I'm going to simply import FileMaker data to a graph and see what exciting new possibilities that gives me. Second, I'm going to build some interaction between my FileMaker database and the graph database. And third, I'm going to try to get rid of FileMaker tables and fields and rely solely on the graph for my data. Is that possible, and how far will that take me, and how cumbersome will that be? Okay, so this is the program. Little disclaimer, I'm no graph expert. It's for more than a year now that I'm studying this subject, but I'm not graph certified yet. So I'm a FileMaker developer. I'm curious. I'm looking at the horizon. What's new there? What are the new technologies? And can this be of interest for a FileMaker developer? That's the point of view. Second, I will be using one particular graph database provider, Neo4j, in my examples. And I will be using some of their slides with their permission. But I'm in no way affiliated with that company. I just use their examples because they have a free downloadable community edition. So you can all download it, not during my session, please, but you can download it today on Mac or Windows and try for yourself. And they have very user-friendly tutorials. So personally, me as a simple FileMaker developer, in 15 minutes I was up and running and doing my first queries with Neo4j. So I'm going to use that one. But there are alternatives like Amazon's, Neptune, and others. Okay? And then third, there will be some JSON and curl involved at the end of the demos. This is not a session to explain you how to use JSON or curl. I need it to do API calls, but I will not explain in detail how API calls work. Okay? So that said, we are on an adventure together, like the famous Belgian comic hero, Tintin. So I am Tintin, and I'm looking around, and hey, a graph database, what is it? And so I'll show you around, okay? Let's go. Why talk about graph databases? What's Sorry, I managed to turn this off while talking. Okay. Who has a LinkedIn page? Yeah, most of you, or a Facebook page for that matter. Have you ever looked at that page and looked at the list of recommendations you get for new people? So I mean this page, right? And it shows you the number of mutual connections that point toward a person you might know, okay? Now, if I show you my live LinkedIn page over here, you see it's this list, more suggestions for you with the number of mutual connections. And they are somehow ranked. The best matches get on top, mostly based on the number of mutual connections. Now, what I want to point out is that while I am scrolling down this page, new results keep popping in, right? So there are some queries in the background happening almost in real time. And first I thought, okay, this is preloaded somehow and it will stop after a while. So I tried this for you for a whole day long. I've been scrolling and scrolling and scrolling. And believe me, it never stops. So it keeps going on. So these queries are really live queries while you are scrolling. Now, to give you an idea about the complexity of these queries, suppose the yellow dot in the middle, that's me. And the green circle, these are my LinkedIn connections. So I have almost 600 LinkedIn connections, okay? Now, if each of these connections also has 600 connections on LinkedIn, this gives me a record set of 360,000 records to operate on, okay? That's not very big, but that's not a small thing either, okay? And so there are on my green inner ring nodes that point toward new unknown nodes to me on the outer ring, on the blue ring. And there might be several nodes from the inner ring pointing toward the same node on the outer ring. Those are the interesting suggestions for new people for me, okay? So somehow these results need to be ranked by the number of nodes pointing toward a new node. That's one thing. Second, on the outer ring, there might be nodes from the green ring as well, because people I know may know each other. So those need to be filtered out, okay? So this is what is happening in the background while I am scrolling down through my LinkedIn page. To give you an idea, this is a so-called recommendation engine. Now, suppose your client asks you, can you build a recommendation engine for me? I was wondering myself, can I do that with FileMaker? This kind of queries and achieve this kind of speed? Maybe not. Well, I tried it, and I'll show you in a second what happens if you do that with FileMaker. But I was wondering, like, oh, okay, what is going on there? What database technology is being used to make this happen? And it's not only LinkedIn, but also Facebook or Amazon does it. If you buy something on Amazon, you get recommendations. And even Google, while you are typing in the Google search box, it tries to autocomplete automatically what you are looking for, right? So this is the same kind of power going on there. Can we tap into that with FileMaker? Why not? Well, what's going on behind the scenes, and let me come straight to the point, they are using a different database technology than we do. The FileMaker model is about tables and fields and relationships and primary keys and foreign keys and join tables, right? There is even an organization called join table, okay? So we know that concept of a so-called relational database engine, right? Now, the databases that drive these recommendation engines are not relational database engines. They're so-called graph databases. And what they do fundamentally differently is they store nodes, and you can think of nodes as of records, and they store the relationships with the nodes. So as it is mentioned in the slide, data is connected as it is stored at right time. So they have found an efficient way of storing relationships with the nodes. Okay? Now, what that means is that once I have found a starting node, I can very quickly explore the surrounding nodes. I have, almost at the hardware level, direct access to the nodes that are around it. Okay? They call that pointer chasing. And it appears that computers are very good at pointer chasing. They can do that very fast. So the whole principle is called index-free adjacency. They don't need a foreign key to refer to another record. They just have a node and a hardware pointer pointing toward another node. That's basically the principle. Now, what's the advantage? There are several. Oh yes, I compare that to having a bunch of squirrels, putting them on a starting point and sending them around in the woods, and they bring back the results from the surroundings. That's how I envision what pointer chasing means, okay? Now, what is the advantage? The main advantage is the size of your data. The gray line to the left is the effect of a large data set on a traditional relational database system, like FileMaker. But not only FileMaker, also MySQL, Oracle, SQL Server. All these databases suffer from the so-called join bump. If data sets become large, or if you have a lot of joins to find, it becomes slow, and this effect increases. Whereas a graph database like Neo4j is not that much impacted by the size of your data because you're doing pointer chasing. So you can be in a sea of data. If you find your starting point, you're only crawling the surroundings, so the size of the data doesn't matter, right? The first search for your starting node is an index-based search, so that one will be the slowest. But in case of LinkedIn, that's my LinkedIn login. It takes a while, it takes a couple of seconds to find my node, but once they're on my node in LinkedIn, they have immediate access to the surroundings, okay? So the size of data doesn't have that much of an impact on the query performance. That's the main advantage, but there are others. The second advantage is some types of queries tend to be easier in a graph database than in a relational database. Suppose this simple question in an employee database. Who reports to a manager, John Doe, and what's the head count? Maybe 3 or 4 or 5 or an unknown levels deep in the organization. This kind of recursive queries are hard to do with traditional database systems. In the case of SQL, you need like a statement and multiple sub-queries to do that, okay? Now, the query language that's used for a graph database or Neo4j in particular, it's called Cypher. It's an open source query language, so open Cypher. And the only thing I want to point out with this slide is that this query is much shorter in Cypher than in SQL. And I will show you some simple Cypher query examples later on in this presentation. So, but maybe you can already make sense of it, of what's there, okay? So some types of queries are easier. Who is using a graph database? NASA uses it to build a knowledge graph, a database of lessons learned to prepare for its missions to Mars. eBay uses it. The Panama Papers have been investigated using a graph database to reveal, to connect the dots and to reveal hidden patterns. You can compare a traditional database as Alta Vista. Who remembers Alta Vista? Yeah, okay, it says something about your age. But back when I started in '96, if you wanted to look up something on the internet, you went to Alta Vista. And this was basically a team of researchers trying to make sense of the internet and trying to index new websites, right? But they were completely overrun by Google, because Google relied on an algorithm, the page rank algorithm. And that's basically a graph algorithm. Google puts up the best matches on top based on the number of connections a website receives. Websites referring to other websites, all right? So this to the difference between traditional databases and graph databases. Other fields where graph databases come in, like finding a cure for a complex disease like cancer, requires collaboration between multiple disciplines in a hospital. You can have lab data, genomic data, patient records, and so on. And what happens is data is extracted from these data silos and then uploaded to a graph database to find new insights, to connect the dots again. And I think FileMaker as a workplace innovation platform could play an important role there, extracting data, somehow transforming them, and connecting them to a graph database. Other scenarios very well suited for a graph database. So not only real-time recommendations, as Walmart uses them, but also fraud detection. I have an example of that later on. Network and IT operations. If one router goes down, what happens to my network? And so on, and so on. There's a very interesting video. You'll find the link in my slides. 7 ways your data is telling you it's a graph. Have you ever worked on a FileMaker project and had the feeling that you were fighting against the database? Yeah, I see people nodding. Right. I had once a project for a researcher at the University of Ghent, and as the insights grew, he wanted to add new entities all the time. Oh yes, and now I want to connect this with that. Oh, and now I want a new value list over there, and so on. And I kept adding new tables and new relationships until it became very, very cumbersome. Okay? Well, that might be a sign that a relational database engine, you're outgrowing its capabilities. Okay, what is a graph exactly? I already talked about nodes. So think about a node as a record. For instance, me as a person, I could be a node in a graph database. I will be a record in a FileMaker database, but a node in a graph database. And you see the different colors. Nodes can have different labels. So I'm a person, but I'm also an employee. I work at a company. I own a car. I have a cat, for instance. Okay, so these are different types of nodes. And a node can even have more than one label at once. All right? And then with nodes come relationships, so nodes point toward each other using these pointers. The query language, Cypher, I told you about, is in fact not too hard to learn. Think about it as ASCII Art. A node is represented by parentheses, just as you will draw them on a whiteboard. And a relationship is represented by a dash, then brackets, square brackets, the name of the relationship, another dash, and then a greater than sign that acts like an arrow to point toward another node. Okay, so this is literally the representation of one node pointing toward another in Cypher. For instance, if I have a person named Dan, and I want to figure out who he's married to, I'm doing a query. I'm using a match statement, which is the equivalent of the select statement in SQL. I use parentheses. I want to find a node of type person. That's the column person thing over there. And then I know its property. I know its name. The property is Dan. So the curly brackets are for properties. And once I find this node, I can follow the relationship, married to, toward the corresponding node on the right side. But I don't know what that node is. So I put it in a variable called spouse. And then, this is not in the slide, I can terminate this sentence by saying return spouse. And it will give me the node on the other side. It's not hard, right? If you know SQL, you can learn Cypher as well. Since relationships are very cheap in a graph database, because I don't need tables, primary key, foreign key, joint tables, I can define relationships at a much more granular level than I will do in a traditional database. So I can say Dan is not only married to Anne, but he also lives with her. And she owns a car. And he can drive it. But only since 2011. So note that relationships can have properties. Interesting concept, right? So relationships are equally as important as nodes in a graph database. Okay, let me show you some simple query examples. So I downloaded the Neo4j Community Edition. They are very open source minded, so the community edition is free, it's fully functional. You only need to upgrade to enterprise licenses if you want to do advanced backup storage or clustering and all these things. So this is the Neo4j desktop, and I'm going to create a new graph or a new database if you want. So I'm going to click add. I'm going to do everything locally on my machine. So I create a local graph. Call it my first graph with a password. And there we go. Okay, it's already created. I can now go to the management console. This is a bit like FileMaker's admin console for FileMaker server. And I can start the database engine because it's stopped right now. Okay, you see it's empty right now. I don't have any nodes, no labels, no relationships at all. It's running on my local machine, and I can talk to it using HTTP or HTTPS via this port. So I can do HTTPS calls. It has an API. Let me open the browser. And the nice thing about Neo4j is it comes with a couple of tutorials that are very, very easy to use. But before showing you the tutorial, I'm going to show you a very simple example, how to create two employee nodes and connect them to a company node. Okay? Let's do that. So I'd like to create an employee in my database. I'm going to use the create statement, and I want to create a new node. So a node is this, literally a circle. Okay? And I want to create a node of type employee. So I need a column for the node label, employee, with a property name. I'm going to create a node for my colleague over here, Jan. So there we go. And at the same time, I can connect him to the company he works at. So I'm going to create a relationship as well. The convention is to put relationship names in uppercase. And then the corresponding node will be a node of another type company. So what's happening? I'm creating two nodes, an employee node, a relationship, and a company node, all in one sentence. Okay? It's like drawing on a whiteboard, isn't it? Now, to point toward these nodes, I can put the results in variables. So I'm going to use the variable E for employee and C for company. And then say, return me both employee and company I just create. And there we go. This is the result. I just created two nodes, employee node and company node. Easy, right? No tables, no primary keys, no foreign keys, no restrictions at all. I'm completely free, maybe a bit too free, but that's something else. Maybe we need a business tool or an innovation platform like FileMaker to impose some business rules on this thing. Okay? Now let me create another node. A second node, I'm going to add myself to this database. Joris works at ClickWorks as well. But this time I don't need to create the company because it already exists. So I'm going to cut this and use a match statement to find the existing node, to find a company named ClickWorks. The result I put in a variable called C, and then I can create a new employee and I connect it to C, so the node I just found. So this will create a second employee related to ClickWorks. And there we go. So I now have a second employee working at ClickWorks. And the nice thing about the graph database is this visual explorer. So I can go to this company dot and double click on it. And it will show me the other connections to this node. So this allows you to explore your data in a very intuitive way, right? So two simple query examples with Cypher. To show you more complex examples, I'm going to use one of the tutorials. This one, jump into code, and it will use a simple movie database to show relationships between actors and movies. So this is a 500-line Cypher query that will basically create a bunch of movies and some actors and connect them. Okay? So if I run this query, there we go. Going to display the names. So it builds the database and it returns a sample query showing all movies of Tom Hanks. Right? So you see Tom Hanks in green in the middle, his movies, and then his co-actors. Okay, now with this sample database, I can show you some simple query examples. For instance, find movies from the 90s. Okay, so I'm going to find nodes of type movie. I'm going to use a where clause, as you will do with SQL. Okay, date released between 1990 and 2000, and I'm going to show their titles. Okay, and this gives me a simple list of movie titles. So you can do everything you can do with a traditional database, with a graph database as well. Other query examples. All movies for Tom Hanks. So the starting node is a node of type person with property name Tom Hanks. Okay. Then I'm going to follow the acted in relationship. And I call the corresponding nodes Tom Hanks movies. This is a variable name. And then I'm going to return the starting node and the corresponding nodes. And this will give me this typical star-like pattern over there. Okay. So it's not hard. Okay, let's go one step further. Tom Hanks co-actors. Same thing. These are the movies. And then I follow the acted in relationship in the opposite direction to find other actors related to the same movies. Right? And I'm going to return their names. So these are all the actors that have played with Tom Hanks. We're almost there because our recommendation engine is starting to get shape. This is the complete recommendation engine. How can I recommend new co-actors to Tom Hanks? Find actors that he never has played with, but his co-actors have. And eventually rank them so that more mutual connections come up on top. Okay, well, this is exactly what is happening in this 4-statement sentence. So this one we already know, find co-actors. Then in the second line, from the collection of co-actors, remember the green ring. I'm jumping toward the outer ring, the blue ring, co-actors. Bear with me. Then I need to filter out those who have already played with Tom Hanks, because on the blue ring there can be dots from the green ring as well, so I need to filter them out, right? And of course, I need to filter out Tom Hanks as well. And the other nodes will be sorted by strength. And what strength is, it's basically a count of the number of paths toward that node. So you can order them by number of connections. This is a very powerful concept. So the best matches will come up on top, the nodes with the most mutual connections, right? Okay, let me run this query, and this happens within milliseconds. So what this result set tells me is that Tom Hanks has never played in the same movie with Tom Cruise, but 5 of his co-actors have played with Tom Cruise. This is what LinkedIn does. Okay? So with this, I would like to conclude the basic query examples from Cypher. And yeah, I was scratching my head like, can I do that with FileMaker? I wanted to find out if I could build a recommendation engine with FileMaker. So what I did do was I imported the entire Internet movie database in FileMaker. So I have like 45,000 movies. It's accurate up to spring last year. So try me, every movie title is in there. So let me find, for instance, use quick find, use Red October, boom, there you go. You see, FileMaker does a pretty good job, even with large data sets, right? But it starts falling behind once you are doing multiple joins and complex queries like this recommendation engine. So I tried it. So let me go to Tom Hanks over here. And if I click this button, I will use the go to related record script step to find out the inner ring, then to find the outer ring, and I will use a scripted loop to filter out the dots I don't need, okay? And let's see how long that takes. So I'm clicking this button, and while it's running, because it takes 3 minutes, I'm going to switch to the following topic. It's not milliseconds. So again, this story, inner ring, outer ring. So FileMaker is now using goTo-related record twice to use co-actors, co-co-actors, and to filter them, okay? Now, to wrap it up, main difference between a graph database and traditional database, a graph database connects data as it stores it, so it stores nodes with relationships. Main advantage is that the size of data doesn't have that much of an impact on the query performance, because once you find your starting node, you can very quickly explore the surroundings. Graph databases are becoming a trend, so this is a recent report from dbengines.com. It's a fun website. You can look FileMaker up there. FileMaker is pretty high in the popularity rankings, but FileMaker is in the red line below. These are the traditional relational database management systems. They are the biggest, like Oracle. They will never go away, but they're not really becoming more popular. Their popularity isn't changing. Whereas the green line, these are graph databases, and they are becoming a trend over the most recent years. They are gaining momentum. Gartner has recognized this as well. And with that, I'd like to conclude the introduction. So I'm going to show you now 3 different integrations with FileMaker. And I think I'm right on time. Yeah, perfect. Now let's first switch back to FileMaker. Oh, he's ready. So what happened is I have found 80,000 potential co-actors for Tom Hanks that he never played with, but his direct co-actors have, okay? These are already filtered out. What I did not do was the ranking, because it already took a couple of minutes, okay? So those are not even ranked, so these results are pretty meaningless, right? I would like to see the top 10 based on number of mutual connections. But it takes already minutes just to do the goTo-related record script steps. So this to compare a query speed between FileMaker and graph databases. Okay, so graph databases are maybe a thing, and maybe I can export some of my data to them and see what happens, okay? So I have an example here, a simple personnel database. And this is basically just names, first name, last name, a branch, and then one foreign key, an employee reports to a manager, okay? So a simple primary key, foreign key. So this person reports to the logistics manager, reports to the vice president, reports to the president. That will be me. And I have a lot of people I'm supervising, so I can go down again, okay? Now, what happens if I import this data set in a graph database? What I need to do is just export the FileMaker data in text format, comma-separated format. And I'm going to use FileMaker's merge format because it gives me the titles in the first row. And I'm exporting just the ID, the primary key, the foreign key reports to, and then the names, branch, and job title. All right, so very simple export, this is the result. So first line contains the titles, and then second, primary key, foreign key, name, and so on. Then I create a new Neo4j database, just like I've shown you before. Call that one personnel. And the only thing I had to figure out was that Neo4j, like FileMaker server, is sandboxed. So if I want to import the file, I need to put it in a specific folder. FileMaker server also only has access to the documents folder. So I needed to put my export file in a specific import folder, which is a subfolder from your Neo4j installation. Okay, so on the right side, you see my export file in that import folder, and then I can load this data in my graph. Yeah, this is the file. These are the titles. And this is the statement in Neo4j to import such a text file. So in line 2, you see load CSV with headers, because I had the titles. Okay? I'm pointing to my file, and I'm putting that in a variable called line. And then in the line 3, I say, okay, I'm going to create nodes of type person, and I'm going to use each line from my CSV as input for the nodes. This is line 4, set p equals line. So every line from my text file will become a new node in the database. And since I have titles, every title or every column will become a new property of the node. So I will have nodes with names, job titles, branches, and primary keys and foreign keys. Okay? And the only special thing going on there is the conversion to integer. I'm converting both IDs to integer. Otherwise, they will be loaded as text. Now I have the nodes, but I don't have native relationships in Neo4j. I only have primary keys and foreign keys. So in the second statement I need to run, I'm going to join these nodes together. Because in Neo4j, we don't need primary keys and foreign keys, but we are going to borrow FileMakers to create these joins initially when loading. So what I'm doing in line 2 is I'm summoning two nodes of type person. I label the one P and the other supervisor. And if I find a match between the foreign key from the one and the primary key from the other, then I link them together in line 5, create a reports to relationship between these two nodes. And after running this sentence, my nodes will be connected and I could delete the primary key and the foreign key, because Neo4j doesn't need them. But if I want to establish some kind of interaction between FileMaker and Neo4j, I need to keep them, because FileMaker needs these keys, of course, to link the data. All right? So this is the result after loading my employee database. Okay, I'm going to show you that. I have 580 employees. By the way, the names are fake. The images are fake. These are random images from the internet, but the relationships are real. So this was a real employee database. I just changed all the names and all the images. Okay, let me show you the results. There we go. And I have some predefined queries over here. Show the entire graph. Boom, this is it. So this is my entire personnel database. And I can look at it in a very different way now. I can immediately, thank you. You see immediately some patterns and errors in this database. There are a few clusters that are not connected to the headquarters. This is the spider in the web, this is the president, and this is what I expect, of course, a nice hierarchical structure in my organization. But the reality is very different, right? For instance, take this group over here. This squid, or how will you call it? This is the German branch. You can see that below, and the person's name is Hans Zimmer, and he's head of the German branch, but he's not connected to the president of the organization. He should be, all right? Wouldn't it be nice if I could now go back to my FileMaker and search for this person? Oh yes, indeed, he's not reporting to anyone. Wouldn't it be nice if I could now just select a person, and that would create a relationship on the other side, right? Now let me go back, refresh this screen, and you see it below? The relationship has been created. Now, this doesn't happen automatically. I had to do something to make this work. but it's not hard at all. And it brings me immediately to the following topic, creating interaction between FileMaker and Neo4j. So updating Neo4j from within FileMaker. Now, what I did do was I attached a script trigger to the reports to field. So if I make a change there, it is captured and it is sent over to Neo4j. And how that happens is basically simple. I grab the primary key and foreign key, ID and reports to, and I build a cipher statement. And I'm going to use two of them. One, to delete the relationships, if there's any already existing between these two. And then a second one to create. So this is the delete. But as you can see, I'm using the ID of the person I'm on in FileMaker. And I'm going to delete any eventual relationship that exists, okay? So this is the match statement. Note that I'm using insert text instead of set variable. This is a little trick, but I prefer insert text because there are a lot of quotes in these JSON strings, you know? And by using insert text, I don't need to escape the quotes. I can just paste my text in there with quotes and all. And then in the next statement, set variable, I'm going to substitute the placeholder for the ID, because that's a placeholder there. I'm going to substitute that with the real value of the ID of my record. So, okay, it's two steps, but it makes the process of working with quotes a lot easier. So a little trick. So this is the placeholder, and in the next line, I substitute it with the real value. Okay? So I sent one cipher statement over there to delete the existing relationship, and I'm using insert from URL for that. So you see localhost, the port number we saw before, okay? And I'm sending the query over there with some header information. So this is all curl and JSON stuff, and I'm not explaining that today. But it's very interesting, very powerful. So first sentence, and then the second sentence creates the relationship. So now you see both ID and reports to as placeholders with the create sentence. And then again, insert from URL. So I'm sending two statements to Neo4j. And this enables me to create an interaction between a FileMaker database and a Neo4j. So I can keep them in sync. And I can use all the advantages of FileMaker and all the power of Neo4j. Now that we have an employee database, there's an interesting example I can show you, fraud detection. Let's go back to this employee graph and zoom out a little bit. And there is one particular pattern here. Oh, there it is. You see this pattern? These guys have a special arrangement together. They are all reporting to each other. Note that every relationship and every node is perfectly valid, perfectly fine. It's the pattern that's fraudulent, right? But how hard is it to detect this in a FileMaker database? Let me show you. Yeah, one of the persons, of course, why not, is named Joe Dalton. So I'm going to look for him. So in FileMaker, it's very hard to detect. I can click on the supervisor and then go on and on and on. It's only after a couple of steps that I discover that I'm running in a circle. Imagine that you would need to do this kind of pattern search in FileMaker. You would need to build a script that traverses each of these relationships for each of the 580 nodes, right? So that will probably take a couple of minutes to run, okay? Now, this kind of pattern queries are very simple in Neo4j. So I'm going to close this. And this is the same query in Neo4j. What I'm doing is searching for nodes, and I call them P1, starting point nodes, following the reports to relationship, and I can specify how many iterations or how many hops I want to go away. So in this case, I choose 10. but I could choose 50 or 100 or something, okay? So I'm going to go any hops away up to 10 until I bite back in my tail. And I find eventually the same starting node. So it's a very simple query statement. It's searching for rings, Freud rings. And it runs in milliseconds. So it immediately reveals this pattern. So this is what bank card companies are doing to reveal certain fraudulent patterns of transactions. Okay? It's a very simple example, but this is the basic principle. So even without knowing your starting or ending node, searching for patterns is possible with Neo4j. This is the final point of my presentation. I was very excited with all this, and I wondered, okay, do I still need FileMaker tables? Because all these tables and fields and join tables and relationships, it's cumbersome, and I now had a taste of the freedom of Neo4j. Isn't it time to be a little bit more ambitious in these exciting Claris times and try to get rid of traditional database engines and try something new? So I tried it with my movie database, okay? And I'm going to close this one, and I have a movie database over here. It's a different data set. It's not the entire IMDb, but it's pretty large as well. So this is my back-end database. Okay, so all the data is now in Neo4j, and now I want to build a FileMaker application on top of it. Will that be cumbersome? Will that feel bizarre? Will that be difficult somehow? Well, let me show you. This is the same movie database, this time powered by Neo4j. Okay? And let me try to find a movie. Notice that every keystroke is an API call to the graph. Every click is an API call to load data from the graph. But it doesn't feel special at all. It feels like native FileMaker. And I can click and explore my database a little bit. Okay, I can do the same thing. Search people, Tom Hanks. There we go. Pretty fast, right? It runs all locally on my machine. And it's FileMaker. The only thing I cannot do is show you the toolbar. Because this is all fake. I have only one record in my FileMaker table. It's a virtual record. It doesn't exist. It loads a global field with JSON, and it parses it out in FileMaker fields. That's all. Okay? And of course, I cannot use FileMaker's native quick find now because there are no FileMaker records. So the quick search had to be scripted. But for the rest, it feels perfectly okay. And I started thinking about FileMaker not that much as a database anymore, but as a platform where you can integrate different data sources. And maybe in the future, we will be able to connect this next-gen workplace innovation platform to a next-gen database engine. Okay? So let me show you now exactly the same button I had in my FileMaker database to show recommendations for Tom Hanks. Remember? Okay, so I'm going to click this recommendations button. This time it's powered by the graph database. And it just takes a couple of seconds to come up with the recommendations. And this time they are ranked by importance. So the best matches come up on top. So in this case, for instance, Tom Hanks has never played together with George Clooney, but they share 35 co-actors. And I would like to display them. So I have this little visualization built. And you see Tom Hanks on the one side and all these movies, George Clooney on the other side, and then these 35 people in between, the connecting dots. Okay? I admit this takes a little bit more work. It involves a web viewer with JavaScript and a web server and so on. But you can do that in FileMaker. And finally, to end this presentation, I have one last example. A graph database contains a lot of functions, and a very interesting function is the shortest path function. Suppose you have two nodes and you want to know if they are somehow connected and which is the shortest path between those nodes. So let me take you an example. We have a famous Belgian actor called Matthias Schoenaerts. Have you heard of him? He's famous in Belgium, and he's starting a career in Hollywood now. But I would like to know how this Belgian actor is connected to this Hollywood celebrity star, Tom Hanks, if and how. All right? So I'm going to look for Tom Hanks, and I'm going to click this button. This is the shortest path button. And it immediately reveals me the different steps and how these two actors are connected by the movies they have played in and their co-actors. So I hope this gives some insight into what a graph database can bring to us, FileMaker developers. I have some slides to conclude. Yes, I have a couple of minutes left. So first, there are no real records in the last example that I showed you. Both tables with 100 of records, these are virtual lists to display the quick search list and to display the portal with the actors, and I kept them at 100 records. Okay. The fields in these tables are basically calculated fields. So I send the query, I load it in a global field, and then I parse out the JSON elements using all these calculated fields and using the JSON get element function. But by using calculated fields, I could use FileMaker's layout tools to build a FileMaker layout as if it was a native FileMaker layout, right? So it didn't feel cumbersome at all. It felt like I was building a FileMaker solution, with the only exception that I was working with parsed out calculated fields. And then everything has to be scripted. Every interaction has to be scripted, but these scripts are not that difficult. It's the API calls that matter, but once you have that under your belt, these scripts are pretty straightforward. So I have quick search scripts, and I have navigation scripts from movie to actor and actor to movie. And then finally, all the relationships in this solution are Cartesian joins or fake relationships. They're just meant to put a portal on a layout, okay? And then there's the future, there's Claris Connect. So all this stuff I had to write myself, all these API calls, this will probably become much easier in the near future. And so this kind of interactions will probably be easier to do. If you want to learn more about it, we have sample files included with the presentation, but also on our blog, on the ClickWorks website. We have a YouTube channel, and there are 15 minutes parts of this presentation. Go to neo4j.com, download the community edition, and start playing with it. They have a free O'Reilly book on graph databases if you sign up. And then I regularly tweet about this stuff as well. So we saw what a graph database is, and I showed you 3 examples, different degrees of integration between FileMaker and the graph. And that's it. Thank you. Thank you very much. Please fill in your evaluation. This is my first DEF CON, and I would appreciate to hear from you. Thank you.